All right, everyone. So this is part two. We'll see if I can get this done in just two parts. This pre-assessment we're using for a study guide. So which is a better buy? I'm going to use a ratio table for this. I'm going to go with cans. It doesn't matter to me if cans or cost is on top or bottom. I'm going to put cans on top for this case. And there's 4 cans for $3. Now, one thing I know about this is that 1 can has to cost less than $1. Okay, think about why. 1 can has to cost less than $1. So I'm just going to mess with the ratio table a little bit. And I noticed that they talk about 8 cans. So I'm going to multiply this times 2 because that'll give me 8 cans. And then I'm going to do the same thing to the bottom of the ratio table. And that's going to be $6. And that's exactly like the other scenario. So I believe they are the same buy. Same buy. Okay. So if they're the same buy, it doesn't matter if I buy two packs of 4 cans for $3 or 1 pack of 8 cans for $6. Same exact buy. We could argue about if I want to buy less or more cans, but they're the same cost per can if we break it down. All right, so let's do 5 cans for $6. I'll do cans on top again. No particular reason, just they're shown up first, and then cost. And so 5 for $6. And right off the bat, I know that 1 can costs more than $1, right? I could figure out how much 1 can would cost. I'm going to do that. 1 can, to get to 1 can, I'm going to divide by 5, right? So I do the same thing down here. This gets a little bit funny because there's 1 remainder 1, right? So I need $1 divided by 5 cans. And so if I take $1 and put it 5 ways, think about that for a little bit. Pause it if you need to, because I'm going to tell you in just a second. But 5 cans each share $1. That means they get 20 cents. So I think 1 can costs $1.20. But I think there's another way that this might be kind of nice for us to work on. I'm going to keep going. I'm going to actually go upward. I'm going to go 5 cans. If 5 cans is $6, 10 cans is $12. And if 10 cans is $12, I'm going to say 20 cans is $24. Right? You following me? And if 20 cans is $24, 40 cans, I don't know why. We don't even know what we're buying cans of, right? Canned food or sodas or what. 40 cans is $48. Okay? So we're gonna look at that, and then I'm gonna go a different color, and I'm gonna say the other one, 8 cans, and money or cost, 8 cans for $10, and I'll show you why I stopped at 40, right? Because I know if I know 8 cans is $10. Watch this. I'm gonna go actually down. 4 cans is $5. Right? See if you can understand that one. And then I'm going to jump all the way to 40 because 4 times 10 is 40. And then 5 times 10 is 50. So with the 8 cans for $10, if I had 40 of them, it would be $50. In this one, it would be $48. I think the better deal is 5 cans. I should write that in a different color. I should write that in red. I'm going to write it in green. Totally different. 5 cans for $6 is a better deal. That should be a 6. I probably should say is a better deal. Okay, that's my answer. Okay, I'm going to circle this for the same buy up there too. Let's keep going. Sean made a mix of lettuce seeds. So all this lettuce. So they want to know how many cups of seeds does Sean have to plant? How many cups? So I'm just going to take all this. Half cup 2/3 cup, and 1 1/4 cups. Let me just make sure, right? The mix has 1/2 cup green leaves, so he's going to use that. So 1/2 cup. And then there's 2/3 cup red leaf, so plus 2 and 2/3, sorry. And then and 1 1/4 bronze leaf seeds. I don't know that I know what those are. 1 1/4. So when I'm looking at this, I can't add these all together yet because, well, I have seconds, I have halves, I have thirds, and I have fourths. Okay, so I know that thirds and fourths meet at 12, and I know 2 goes into 12. So I know half of 12 is 6 twelfths. Okay, I know that, well, let me just come over here. 2/3, and I want to go to 12. Okay, so I'm just going to multiply by 4, right? And do the same thing up here. 8. So that's 2 and 8 twelfths. And then I know 4 goes into 12 3 times, so that's 1 whole and 3 twelfths. So I'm just going to add this all up. I'm going to add my whole and my other whole, 2 wholes, so 3 wholes. It's going to be over 12. And then 6 plus 8 is 14, plus 3 is 17. Now that doesn't look right. It has 3 and 17 twelfths. So I can get a whole nother whole out of there. I can get 12 twelfths out of there. So that equals, instead of 3 twelfths, 3 and 12, 17 twelfths, it's 4. And there's 5 twelfths left, 4 and 5 twelfths cups. Circle that to show I'm done. Okay. All right, let's talk about Abby and Greg. This one we might be able to draw a picture. I'm going to keep using just my fractions. So first they want to know who is taller, and they want to know by how much. So I'm just going to write this down over here. Abby. I wonder if you guys could guess who you think is. Maybe we've done enough of these. 5.5 feet. Greg is 5 1/3. Okay, I know halves and thirds go into sixths. So I know half of 6 is 3/6. And then earlier, way earlier, I know a third is 2/6. So Greg is 5 2/6. And check it out. I already know who's taller. Abby's taller. And my work's all over there for the next one. How much taller? Well, look at this. Let's just subtract it. They're both 5 feet, and there's just 1/6. So Abby is 1/6 feet taller. Okay? All right. Let's keep going. See if I can finish the next page. Remember, pause it. Try it first. I remember doing a problem like this the other day in class. Okay. Is that Andrea? Andrea worked out by walking and running on the park trail. She walked 2/5 of the trail and ran 1/4. Notice we don't know how long the trail is. She just, of the trail, she walked 2/5 of it and ran 1/4. How much of the trail she covered? So she walked 2/5, and then she ran 1/4. So let's add those up, right? But we can't just add those. We can't just add those up. I might show my work on the side. Well, let me just do this. I'm going to do something a little bit differently. Let me just list my 5 times 1, 5 times 2, 4 doesn't go in that, 5 times 3, 5 times 4. Okay. I know 4 goes into, well, we just said 5 times 4, right? So I'm going to make them out of 20ths. Both of them go out of 20ths. Okay. 2/5. Let's go over here now. 2/5 to 20ths. Times 4, right? Times 4. 8/20ths. I feel like I just did this one in class, like maybe today. It might have been yesterday. 1/4. Let's show our work down here. And I want to go to 20ths. Times 5. Well, I know what 1 times 5 is. 5/20ths. So she covered, out of, if we broke it into 20ths, she covered 13/20ths of the trail. I am going to circle this because I got a lot of work going on. Did she run or walk farther? Well, we have, let's label this up here. Okay. The 2/5 was 2/5 was walking. So this is walk. So is this. And then I'm going to change the color. Keep changing it. And then this is run. And this is equivalent to it. So it looks to me like 8/20 is bigger. She walked further. And then how much further? Well, I do 8/20 minus 5/20. And I believe it's 3/20 farther, further. I'm going to put farther. That's a 0. All right. I have 4 minutes to finish the last one. Can we do it? You should pause it and try it. I really like this estimation. I really, really like it. So I wish you'd try it. David ran half a mile down the high school track and then walked 1/3 of a mile. Okay. So they want an estimate. More than a mile. Well, I know that 1/3 is less than half, so it's not more than a mile. Not this one. More than half a mile. Well, yeah, because there's a half mile. But less than a whole mile. I think it's that one. But let's just double check. Less than a half mile. There's no way it's less than a half mile because he ran a half mile, then went further. So it can't be that one. There you go. I eliminated him. All right. How far did David go in all? He used numbers, labeled sketches, or words. I'm going to use numbers. So he ran half. And then he also went 1/3. And we've talked halves and thirds meet up at 1/6. So half of 6 is 3/6. And we've done 1/3 a couple times. To 6, it becomes 2/6. So now we have an answer. 5/6 of a mile. That's how far he went. 5/6 of a mile. Okay. Now we got Sarah. We'll talk about Sarah for the last couple minutes of this. Sarah solved the same problem, and she got 2/5. I know what she did, but I'm not going to even write it down. Look what she did. She added the numerator, and she added the denominators. Now think about this. If he already ran 1/2 mile, well, half of 5 is more than 2, right? So I'm going to write no. She couldn't be right. It's not reasonable because the answer should be greater than 1/2. She really needs to find a common denominator, right? You cannot just add those up. You know, that's how we started when we started doing. You cannot just add two fractions with different denominators. All right, you guys. I really, really want you to study these, practice these, look at them, and make sure you understand them. Bring questions back to me. If you have them, you can always email me. You can rewind this or rewind it or start it over. I guess you don't rewind. We don't rewind anymore, do we? We just pull the little thing back a little bit. Sorry, I'm outdating myself. Okay, you guys are awesome. Thanks for checking it out. Make sure you bring in any questions that you have. Take care, guys.